Now, number 3 seems like it gives a lot of students trouble. It's a little bit simpler than you might think. The density of copper is listed at 8.94 grams per cubic centimeter. 2 students each make 3 density determinations of samples of the substance. Student A's results are 7.3 grams per milliliter, 9.4 grams per milliliter, and 8.3 grams per milliliter. Student B's results are 8.4 grams per cubic centimeter, 8.8 grams per cubic centimeter, and 8.0 grams per cubic centimeter. Compare the 2 sets of results in terms of precision and accuracy. Now, in terms of what the question wants, it's very simple. If you're to look at the data that student B was able to generate, student B is both more accurate and precise, meaning, on average, student B's measurements of 8.4, 8.8, and 8.0 more closely approximate the correct or accepted value of the 8.94. Now, you don't have to eyeball this. It's not necessarily necessary at all. We can go back to number 1. How is the average for a set of values calculated? Oh, we know how to do that now. You can actually calculate the average of these 2 sets of numbers. And if you do that, you will find that student A's average is 8.3 grams per milliliter. Student B's average is 8.4 grams per cubic centimeter. They're not that far off. Yeah, they're not that far off. It's kind of surprising that student A's average is that close to student B's, since they definitely seem to be a little more widespread, larger standard deviation, but they are fairly close. However, notice that student B's average is closer to the accepted value, so that makes student B more accurate. Also, when you try to, you don't have to actually do a standard deviation calculation here. You can simply compare the results to the averages. Student A, his average is 8.3. Well, one of his measurements was 1.0 off. Okay, that's down, 1.0 down. Then he had one measurement that was 1.1 over. Okay, so again, we're averaging one away from your average. That's a pretty large standard deviation. And he's got one that's actually right on the average. And so he's swinging around 1 from the average each time. But when you look at student B, we have one measurement that's right on the average. We have one measurement that is off by 0.4, and then a second measurement that is off by 0.4. And so you have a lack of precision that is shown by student A's values missing their average by a greater margin than student B.